Hello, dear learner, Form 4s everywhere, wherever you are, and some Form 3s who are interested in my revision videos. Welcome back to our lessons, and this one is a special dedication to one student in Nakuru City called Glorious. This one wrote to me on YouTube and told me to check on these a few revision, and the questions that you sent me through my email, I'm ready to do them in this video. We have around 3 questions. And the first one is going to be from indices and the laws of indices. Question 2 will be about surds, cause rationalizing the denominator, and the third one will be the further logarithm topic, or the laws of logarithms. So let us write these questions and of course calculate them together with you. Question 1. Solve for x. Solve for x in 9 power x times 27 power x minus 1, close the bracket, is equals to tan 30 degrees. Tan 30 degrees. So this is a question that incorporates 2 concepts. Of course, it has some trigonometric operation, and of course with the indices. So the first thing you do, and of course this question, I think we should have also reminded me that it said without using mathematical tables or calculators. That is very crucial to indicate that, because we don't want to read this one, we want to use another method that will not be a table or calculator. So what we do here, we first of all, solution, we first of all write the prime factors of 9 and 27. So we shall have 9 is like 3 squared, and of course times that x that we have there. So 3 power 2x multiplied with 27 is like 3 power 3. So 3 raised to 3, and then the bracket x minus 1, and you close the major brackets, and then is equals to tan 30 degrees. So we can do the left hand side exhaustively, so that we have 3 power 2x times 3, you open the bracket here, 3x minus 3, which should give us again 3. When it's a multiplication, the powers are added. So we have 3 base 3, 2x plus, you open the bracket, 3x minus 3, like that, which should be 3 power 2x plus 3x minus 3, 2x and 3x. When you add them, you get 5. So 3 base 3 power 5x minus 3. So the left hand side has been exhaustively been done. So what is remaining is tan 30. And in this case, tan 30 should give us some surd or some value, and we use what we call, the special triangle. We use the special triangle, a method of getting tan 30. Yeah, so we have 2 special triangles. The first one, and the only one that I want us to use, is the equilateral triangle. This one is an equilateral triangle, and this angle is 60 degrees. This one is also 60 degrees. Now the whole of it is 60, so this one is 30, and this is 30. We have special triangles, we have 45, we have 30, we have 60. But now in this case, we want to use this special triangle of this equilateral triangle. And again, the angle that we are having here should be the base angle. That means this 30 degrees. So we take this triangle, or this one, and then we make sure that 30 degrees is the base angle. So we can invert it a little and come up with such kind of thing. And this means 90 degrees is here. Then this now becomes our base angle. It is there, 30 degrees. The rest we are going to arrange. Now suppose we have the angles already. Suppose the sides were 2. This was 2. This is also 2. And the whole of it is 2. But this one is 1 and this is 1. Because it has been subdivided into 2 equal parts. So what am I doing? I'm looking for the value of this height here. So that height, we are going to apply the concept of Pythagoras theorem, which is h squared is equals to 2 squared minus 1 squared. So this is going to be h squared is equals to 4 minus 1. So h is going to be the square root of 3. So the height at the middle is going to be root 3. And it is going to apply on both in both triangles. So this is root 3. And because we inverted our triangle like this, one came here, and then of course the other side, the hypotenuse remained the same. The hypotenuse remained the same. Just before I invert it, let me first of all redraw it. If we invert like this one comes to root 3, and then 2 remain the same. So I can do it again here. So we have root 3 taking now the position down here. After inverting it like this, because I'm interested in making 30 degrees the base angle. This is 30. So 2 is still at its position, the hypotenuse, and then 1 came here. This is an inverted triangle to ensure that 30 degrees is the base angle. So what am I doing? I'm looking for a side. That is to say, we have what we call SOHCAHTOA. SOHCAHTOA from trigonometry form 2. SOHCAHTOA. If it is tangent, it is opposite over adjacent. So opposite is 1. So tan 30 degrees is equals to opposite, which is 1, over adjacent, which is root 3. So all that business of ensuring I bring to your attention the special triangle equilateral is to ensure that we get tan 30, which is 1 over root 3. And once we have that one, we now get back to our question. Tan 30 is 1 over root 3. Tan 30 is 1 over root 3. So we have done the left hand side, which is equals to 1 over root 3. So we can continue with the laws of indices now. We can still do some little adjustments on root 3. Root 3 is like 3 raised to a half. Very good. The square root of 3 is like 3 raised to a half. So we have sorted that one again. So we can say 5x minus 3 is equals to 1 over 3 raised to a half. We also want to do one more thing. We want to make this one 3 go up there so that we can have common basis. So again, we are going to do the reciprocal, which is 5x minus 3, or the inverse. The inverse of this is going to be 3 negative a half. When it goes up there, it becomes 3 negative a half. So at this point, we have made the arrangement of the bases, and now we can take the powers. When the bases are similar, similar bases are dropped. Similar bases are dropped, and then we take the powers. So we shall drop base 3 and take 5x minus 3 is equals to negative a half. So we have 5x is equals to negative a half plus 3. 5x is equals to 3 minus a half, 2.5, right? So 2.5 in fraction form is what? 2.5, which is 5 over 2. So our 5 over x is equals to 5 over 2. You can divide by 5 on both sides. So you get x is equals to 5/2 times 1/5. So x is equals to 1/2. Important points to note here, apart from the laws of indices, we use special triangles to get the values of trigonometric functions or angles given. So that is it. That is why I'm saying the laws of indices also incorporated the aspect of trigonometry form 2. That is the first question. Second question. So the first one done. Second question. Question 2. Rationalize the denominator. Rationalize the denominator. It is 2 over 1 minus tan 30 degrees. Again, we use special triangles. I have already shown you how to get tan 30. So what we do is we have this triangle, we'll repeat it briefly. This one, and then we said this is 1, this is 1, this is 2, and this is 2. This is an equilateral triangle, so all sides are equal. And then the middle one is √3. And because our base angle is 30 degrees, we invert the triangle to take this position. When you invert the triangle, what happens? Opposite goes to adjacent. So 1 goes here. Then the √3 comes to the adjacent like that, but the hypotenuse maintains its position. So what happens is at this point we have 30 degrees. Again, because I've already done it, you know very well that tan 30 comes from TOA, which is opposite over hypotenuse. It will be 1, which is 1, opposite is 1, opposite over adjacent is 3. So you come and substitute that one in this, then you rationalize. So 2 over 1 minus 1 over √3. Then from this point, I think we can rationalize. To rationalize is to make irrational numbers, especially when we are rationalizing the denominator. We are making it, because it is irrational, we are making it rational. So we multiply with the conjugate. The conjugate of the denominator. The conjugate is 1 plus 1 over √3. This one is the conjugate. So we multiply by the conjugate, which is 1 plus. The conjugate means the sign is the only difference. Of course, what it brings is what we call a difference of two squares. So what you do in the denominator, you do it on the numerator. So 1 plus 1 over √3. So the numerator is simply going to be 2 into 1 plus 1 over √3. Then the denominator will be a bit more technical. We need to do an expansion. But remember, we have a law in quadratics that talks about a difference of two squares. When we have a plus b times a minus b, this one is an identity where we simply say a squared minus b squared, a difference of two squares. A difference of two squares. So this is the concept that we apply. So instead of us expanding, but of course you can still expand. Instead of us expanding 1 times 1, we say 1. 1 times this plus that is plus 1 over √3. This negative times 1 is minus 1 over √3. 1 over √3. Then minus 1 over 3. This one cancels out. This is now expanding. But instead of doing that, you can simply say, by this concept, 1 square minus bracket 1 over root 3 square, which gives you 1 minus this one is a third, which is going to be 2 over 3. So at this point, you can apply the concept of a difference of two squares, or you simply expand. But this is the easiest and the shortest and most appropriate method to get to multiplication of value by its conjugate. So at this point, we have the numerator. We have the numerator. We have the numerator. The numerator is 2 into bracket 1 plus 1 over root 3. And of course, the denominator now, after all this conjugate and whatever multiplication, we have 2 over 3. 2 over 3. So you operate these 2. So 2 divided by 2 over 3 is like 2 times 3 over 2. Cancel, cancel. So your answer is 3. So if you divide here, you will get 3. And so your answer is 3 into 1 plus 1 over root 3. This one can be written as 3. If you open the bracket and have 3 plus 3 over root 3, you have made it a little bit complex. So what happens is you can leave your answer at this point. Leave your answer at this point to avoid complicating your values, because every time it is about simplifying your values. So quickly and very briefly, we have known how to get trigonometric surds from trigonometry, and we have also learned how to multiply a value by its conjugate, and of course the concept of rationalizing the denominator and how you bring numerator over denominator, because at this point it was numerator over denominator. Second lesson, second question down. We go to the last one, which is further logarithms. Solve for x. Question 3. Solve for x. Solve for x in log to base 3 of x squared plus log to base 2. Log to base 2. Log to base 2 of x cubic is equals to 10. So that is a function. These are an equation, a logarithmic equation. So in solving it, there are a few things we need to understand. Number one, this question requires us to let. I like calling them questions that requires us to let. So in this case, we can let log to base 2 of x be, let's say, t. We let log to base 2 of x be t. So what we do, we will put this t here. But before we go to arranging it with this t that we want to let, something is very unique here in this part. We shall make sure that this 3 goes before log, so that we remain with log to base 2. In other words, we shall have log to base 2 of x, everything squared, plus 3 log to base 2 of x. In this case, we have simplified our value here by ensuring that 3 comes to this end. That is a log is equals to 10. So we can go ahead and apply the concept of letting. So if this is t, then this is going to be t squared plus 3t is equals to 10. Already we have landed in what we call quadratic equation. When you are at a quadratic equation, you arrange it in form of ax squared plus bx plus c is equals to 0. So 10 goes to the left hand side. T squared plus 3t minus 10 is equals to 0. So the easiest method and the most convenient method of solving for t, because we shall first of all solve for t, after which now we shall solve for x. So we can use the factorization method, product sum. It is our most favorite, product sum. So two numbers, if you multiply them, you get negative 10. This is 1 here. I'm assuming this is a perfect square. And when you add them, you get positive 3. The values are 5 and what? And 2, but 2 must be a negative. So that if you add 5 plus negative 2, you get 3, and 5 times negative 2, you get negative 10. So you take these values and arrange them in the position of b. So you will have t squared, t squared plus 5t minus 2t minus 10 is equals to 0. We have made these values to be 4 so that we can pair them up and factorize. Pair them up and factorize. So t and 5t, t squared and 5t common factor is t. So we remain with 1t inside. 5t divided by t plus 5. Then negative is common, and then of course 2 is also common. So if you divide this one by negative 2, you get t. It must be the same as this one. It must be the same as that one. Negative 10 divided by negative 2, positive 5 is equals to 0. So at that point, you take t minus 5, t minus 5, t minus 2, yeah, t minus 2, multiplied by t plus 5, t plus 5 is equals to 0. When you are multiplying two values or two elements and the answer is 0, either or both of them are zeros. Assume t minus 2 is equals to 0, then t is going to be positive 2. And if t is positive 2, you bring it back to this point. And you say, remember, log 2 base 2 of x was t. And because t is now 2, this is a logarithmic notation. You write it in index form. So you note it power form. So you will say 2, this is always the base, and this is the power. This is, so 2 power 2 is equals to x. So the value of x is 4. That is the first value of x. When you are solving a quadratic equation, you must get two values. When you get two values of t, you mean you are also going to get two values of x. We are now with the second value. Now, if t is t plus 5 is equals to 0, then t is equals to negative 5. Remember, log 2 base 2 of x is equals to t, which is negative 5. Again, 2 power negative 5 will give you x. 2, let me look for some small space here so that I can wind up. 2 power negative 5 is equals to x. This one is log notation, this is index notation. So x is equals to 1 over 2 power 5, which is 1 over 32. You can still say, when you do the reciprocal, it's like you do the inverse. To remove this negative, it has to go down here. So the values of x are 1 over 2 power 5 is 32. 1 over 32, or x again is 4. That is how you approach this question. Very important things to note in this question. Number 1, you operate this power 3 dropped to in front to become here in front of log 2 base 2 of x. Another point, you let log to base 2 of x bt, and then you apply that one. Solve the quadratic. If you are not going to get 2 values of t, you may miss a mark. You must get 2 values of t, and that means you get 2 values of x. Glorious, Getoka, from wherever you are, watch this video, share it with your friends, and please do more requests, and I will continue giving you the best. Wilfred Bomanyi Ukangi, hyphen Kiongozi. Let us meet in our next video.